which prints the value of x, and line 6, which prints the type of x. Here in line 4, I assign a value to x, and if I assign it the special literal true with a capital T, you'll see when I run it that the class is bool, and the representation in the string is the word true. And likewise, if I use false here, I also get the class is bool. So the bool type is for logical values and expressions. For example, here if I say 7 is greater than 5, I'll get a bool type true. And I'll save and run that. X is true. This is because the comparison operators return true or false in the bool type. It's worth noting at this point, and I have a reason for this, we're going to use this, and you'll need to understand that there is a special type, none, and it's the none type. If I save this and run it, you see the value is none and the class is none type. The none type is used, and it has only one possible value, which is none, and this is used to represent the absence of a value. To represent the absence of a value. And there's a reason I'm showing you this at this point. If I come down here and I say if x, print true, else print false, and these are strings here. So when I save and run this, you'll notice that with the value of none, the logical test here in if returns false. So it's worth noting that there are a few things that evaluate as false. Any numeric 0, so if I save and run this, x is 0, class is int, and the test is false. Any empty string, so if I just try this, I have an empty string, class string, and it evaluates as false. So I put anything at all in that string, it's no longer false. So I'll save and run this, and it's now true. And if a number is not 0, again, it'll return true. It'll evaluate as true. So like many languages, you can use any type as a logical value as long as you know the rules. None evaluates as false. 0 evaluates as false. And an empty string evaluates as false. Pretty much none evaluates as false. 0 evaluates as false, and an empty string evaluates as false. Pretty much anything else, at least in the default types, will evaluate as true. So the bool type has two possible values, true and false, and additionally, many other types may be used as logical expressions and will be evaluated as false if they're effectively zero or empty, false if they're effectively zero or empty, otherwise they will be true. We'll see other examples of this behavior later in this course. Python provides some built-in sequence types, including lists, tuples, and dictionaries. Python provides some built-in sequence types, including lists, tuples, and dictionaries. Here in Komodo, I've opened a working copy of sequence.py from Chapter 3 of the exercise files. A list is created with square brackets like this here on. A list is created with square brackets like this here on line 4. And if I save and run this, you'll notice that we get this result: I is 1, I is 2, etc. The for loop is sequencing through the list, and for each item in the list, it assigns I the value of the item, and I is used in the print function. A list is a mutable sequence, so I can reassign one of the values after I have assigned it. I can say x sub 2 equals 3, and so I'm accessing with this index in the square brackets, I'm accessing a particular A list is a mutable sequence, so I can reassign one of the values after I have assigned it. I can say x sub 2 equals 3, and so I'm accessing with this index in the square bracket, I'm accessing a particular specific item in the list, and I'm going to change its value to 42 like that. And so when I save and run it, you'll see that the item number 2, which is the third item, because the index starts at 0 for all sequence types in Python, and I've reassigned that to the value 42. So I can say item number 0 or all the way up to item number 4, and it will reassign or all the way up to item number 4. And it will reassign that value. Now, on the other hand, a tuple is exactly like a list, only it's immutable and it's indicated by parentheses. And so if I try and run this with a tuple instead of a list, you notice I get the error, type error, tuple object does not support item assignment. That's because a tuple is not mutable. You cannot change it, or sometimes it's referred to as being immutable. So if I remove this line and run it again, you'll notice that it works exactly like the list. I find that it's generally a good idea to favor the immutable type tuple to favor the immutable type tuple over the mutable type list unless you know that you need to change the elements in the list. So I'll tend to use the parentheses by default and only use the square brackets when I know that I need to change something. You can also create a sequence using range. And so instead I can say here range sub 5 like that. And when I save and run it, again, it starts at 0 and it ends at the number before what you specify. So that end is actually the last item minus 1. So when I specify a 5, it'll end at 4. If I specify a 10, save and run that, you notice I get a sequence only up to 9, and it also starts at 0. I have to scroll backwards to be able to see that. There's actually 3 possible parameters for range. If you give it just one parameter, it takes us as the end mark. There's actually 3 possible parameters for range. If you give it just one parameter, it takes us as the end mark and it starts at 0. I can change the start. I can say start at 5 instead. And when I save and run this, you notice I get 5, 6, 7, 8, 9. Or I can say end at 50, but step by 5. And when I save and run that, I get 5, 10, 15, 20. So that third parameter is a step by. If you specify all 3, they're there's actually 3 possible parameters for range. If you give it just one parameter, it takes us as the end mark and it starts at 0. I can change the start. I can say start at 5 instead. And when I save and run this, you notice I get 5, 6, 7, 8, 9. Or I can say end at 50, but step by 5. And when I save and run that, I get 5, 10, 15, 20. So that third parameter is a step by. If you specify all 3, they're start, end, and step. And if you specify just 2, it's start and end. And if you specify just 1, it's just end. And so if I save and run this again, I get 0, 1, 2, 3, 4. Like the tuple, a range is not mutable. So if I try to say x sub 2 equals 4. Like the tuple, a range is not mutable. So if I try to say x sub 2 equals 42, save and run, I get this error, type error range object does not support item assignment because it's immutable. If I want a mutable list, I simply construct a list with the result from range using the list constructor like this, and save and run it, and now I have 0, 1, 42, 3, and 4. A dictionary is a searchable sequence of key value pairs, and you can construct it like this. And so that's a dictionary, and if I just save and run this, you notice that I get I is 1, I is 2, I is 3. I'm just getting the keys. I'm not getting the values. If I want to get the keys and values, I can say in my for loop key comma v in x dot items. So that'll actually return a 2 tuple of each of the items with the key and the value. And then I can print it out like this. I can say key and value like that, and it will print the key and the value for each element in the dictionary. Now, each of these values, the keys and the values, can be any type. And the same is true. Now, each of these values, the keys and the values, can be any type. And the same is true for lists and tuples. Any element can be any type. And dictionaries are mutable. So I can come up here and I can say x sub 3, and use the key to index it, equals 42. And when I save and run it here, you notice that key 3 now has a value of 42. So this is an overview of Python Python's built-in sequence types. And you'll see a lot of examples of these in the rest of the course. These built-in sequence types are very useful and flexible. In Python, everything is an object, so a type is the same as a class. Here in Komodo, I've opened a working copy of types.py from chapter 3 of the exercise files. And down here on line 4, I'm going to create a tuple with 5 elements. I'm going to say 1, 2, 3, 4, 5. And when I save and run this, you notice that line 5 prints a representation of that tuple, and line 6 says that the type is class tuple. Now, where this starts to get interesting is when I make this tuple into something else. We'll change this to a string that says 2. We'll change the 3 to a float. Change the 4. We'll just make that a list. The number 4 and a string 4. And we'll leave the 5 alone. So when I save and run this, now you'll notice that the string representation printed out on line 5 is exactly this structure that I've created there. And line 6 still says type tuple. But if instead I ask, well, what's the type of that second element, which would be element number 1. Remember that these indices start at 0. And if I save and run this, it now says, well, that's a string. So this is useful information. I can inspect any element in my structure and I can say, well, what type is that? On the other hand, if I bring this back to the type of X, and let's just duplicate this and make a Y that's got exactly the same stuff in it. And I'll ask for type of X and type of Y. We get the same result for both of them. But instead of type, if I ask the ID, and I'll do that for both of these, I save and run, you'll notice I get 2 different unique numbers. So these are 2 different objects. ID function returns a unique identifier for each object. Now, if I ask for the ID of x sub 0, I have that literal number 1 there, right? And y sub 0 also has a literal number 1. Then we save and run this and we find out that they're exactly the same because there is only one literal number 1 object. There's no need for Python to create two different objects for the literal number 1. So I also have an is operator, and I can say, well, are these two different things exactly the same? I can say if x sub 0 is y sub 0. This checks to see if they are exactly the same object. So I print, yep, if they are, and else print, nope, if they are not, and I save and run that, and they are the same object. But if I'm just asking if x is the same object as y, then, oops, that's not where I wanted to do that. Well, I can do that anyway. I want to do that here. If I just want to know if x is the same object as y, then I can save and run, and I can see that, nope, they are not the same object. Even though they have all the same values. object. But if I'm just asking if X is the same object as Y, then, oops, that's not where I want to do that. Well, I can do that anyway. I want to do that here. If I just want to know if X is the same object as Y, then I can save and run and I can see that, nope, they are not the same object. Even though they have all the same values. Now, this is all very useful, but if I want to know, is this particular object a list or is it a tuple? None of this is going to help me. I can't say if type of X is equal to tuple because that's just never going to work. It's going to say nope. On the other hand, there's a special function called isInstance. IsInstance. If isInstance X tuple. Save and run. And you'll notice it says yes, it is. It says, yep, X is a tuple. Is X list? Well, I can say elif. Yeah, it's not exactly right, is it? It's like this. I can say print list, and here I can say print tuple. Now, if I save and run this, I can see that X is a tuple. But let's make Y a list instead. And I'll come down here and I'll test for Y. Save and run, and we see that Y is a list.
Prone.
So if you want to know, for instance, you're going to handle different, and I'll come down here and I'll test for y. Save and run, and I can't say if type of x is equal to tuple, because that's just never going to work. It's going to say nope. On the other hand, there's a special function called isInstance. IsInstance, if isInstance x tuple. Save and run, and you'll notice it says yes, it is. It says yep. X is a tuple. Is X list? Well, I can say elif. Yeah, it's not exactly right, is it? It's like this. I can say print list, and here I can say print tuple. Now, if I save and run this, I can see that X is a tuple. But let's make Y a list instead. And I'll come down here and I'll test for Y. Save and run, and we see that Y is a list. So if you want to know, for instance, you're going to handle different types differently. If a particular object is of this type or of that type, this is the way that you do it. You use is instance. If you want to print out what type something is, then you can use the type function like this. Save and run, class tuple, class list. And that'll print out that value. Although that's not something that you can easily test against. For that, you use is. You can easily test against. For that, you use is instance. And if you want to know exactly what the specific ID is of a object, you can use the ID function, and that will print their IDs. And you can use the is operator if you want. Want to know if two objects are the same object. So these functions work by using Python's class introspection. So these functions work by using Python's class introspection, and they do come in So these functions work by using Python's class introspection, and they do come in handy. We'll see examples throughout the rest of this course. We'll see examples The Python syntax for conditional statements is consistent with the rest of the Python syntax for conditional statements is consistent with the rest of the language. Here in Komodo, I've opened a working copy of conditional.py from chapter 4 of the exercise files. This is an example of the conditional statement in Python, and it should look familiar. We have if, elif, and else. If and elif require a condition. In this case, we're just using the Boolean constant true and the Boolean constant false. And else is optional. Condition. In this case, we're just using the Boolean constant true and the Boolean constant false. And else is optional. So if I save this and run it, we see if is true. If I make that false, the execution should go all the way to the else. Also, when we have neither is true. And if I make the elif true, then it has elif true. Of course, I can have as many elifs as I want to. So we'll number them. Elif 1, LF2. Let's move this down a little bit so we have more room to edit. 3 and 4, and I can just pick one and say I'll make this one true. And of course, it'll say LF3 is true. So you can cascade the else ifs to as many as you want. And this comes in. So you can cascade the else ifs to as many as you want. And this comes in handy when you want to do something like this. X equals 5. If x equals 0, then 0 is true. And we need to make that a double equals. If x equals 1, and 1 is true, or we can just leave these numbers here because those will match up. And so this works very much like a switch statement does in other languages. And when I save and run this, we see that LF5 is the one that is true. And of course, if we change this to 42, then we get the none of them are true. So the conditional statement in Python is simple and easy. It uses the familiar if-else, elif keywords and the typical Python indented block syntax. Python tends toward a minimalist language. And as such, it provides a minimally complete set of operators for use in conditional expressions. And as such, it provides a minimally complete set of operators for use in conditional expressions. It has comparison operators for equal, not equal, less than or equal, and greater than or equal. It has logical operators for and, or, and not. It has identity operator It has logical operators for and, or, and not. It has identity operator that tests if two objects It has logical operators for and, or, and not. It has identity operator that tests if two objects are the same object. And so it has is and is not. And it has a membership operator, which is true if a variable is a member of a collection. So it has both in and not in for membership. These operators are commonly used in conditional expressions. You'll use in conditional expressions. You'll see many examples throughout the rest of this course. Python tends toward a minimalist language, and as such, it provides a minimally complete set of operators for use in conditional expressions. It has comparison operators for equal, not equal, less than or equal, and greater than or equal. It has logical operators and or not, has identity operator that tests if two objects are the same object. And so it has is and is not. And it has a membership operator, which is true if a variable is a member of a collection. So it has both in and not in for membership. These operators are commonly used in conditional expressions. You'll see many examples. Beginning with version 2.5, Python includes a ternary conditional operator. It's important to note that this operator does not work in versions of Python previous to Python 2.5. Of course, we're in Python 3.6 here, and so we can demonstrate it. Here in Komodo, I've opened a working copy of ternary.py from chapter 4 of the exercise files, and this has a simple example of the ternary operator. So down here on line 5, we assign X to be this string, feed the bear now, if hungry. And we have this hungry variable above, which is set to the logical value true. So that's being tested here in this if clause. And there's an else that says, do not feed the bear. So if the bear is hungry, then The string will be feed the bear now, and if the bear is not hungry, then it will be do not feed the bear. So when I save and run this, it says feed the bear now. And if I set hungry to false, and remember 0 works fine for false, I save and run and it says do not feed the bear. Now it's important to note that all of this is required. If you're going to have the ternary conditional operator, you must have both if and else. You must have both clauses. Of course, if you want to, you can have else set it to none. And so when I save and run, it'll say none. But you must have an else clause. It's the if clause. The ternary conditional operator is used occasionally, but it can be very convenient in some circumstances. Python has a full set of arithmetic operators.